Hello Internet, what is going on? So this week we are focusing on math, and before we get into that I want to have a quick pivot or an update. With the Road Less Traveled, I'm going to continue this, but I'm going to focus primarily on books. Books will be the primary path that I learn through, and then I'll have supplementary paths like Wikipedia, lectures, random blogs, etc. to kind of supplement the content I'm getting from the book. But I want to be book primary because that is, for me, the best way I learn, and also it's good to have some sort of structure on the path that I'm learning, irrelevant of the topic. So that's a bit of an update. And then a side rant I want to have before I get into this math is reading hard books. So over the last year, I've started incorporating and mixing more hard books into my reading curriculum, I guess. And I don't read only hard books, but I tend to try to read at least 50-50 or maybe 40-60, 40 hard, 60 easy. And when I define hard is relative to the person. It's subjective. So you know more about a certain topic than I do, and I know a bit maybe about some other topics that you don't. So when we pick up books, picking up a book that is challenging to you, I think is a good thing, because even if you only understand 30% of what you read, you actually walk away understanding so much more about that topic than you would if you haven't picked it up. So even if it's 30% of what the entirety of the book, that 30% is a huge 30% for you. It's a huge leap in your knowledge and understanding of the world around us. So by going through the process of struggling through some of these hard books, which I've struggled through many, you actually start to build up a muscle, I think, as well, as a reading muscle, or maybe a pain tolerance. Your pain tolerance increases, so you're able to endure more pain from hard books, because they start to become slightly easier, or at least more intriguing. So this is my side rant and plea to you to read more hard books. And then this week is a book all about math. So the book is called Love and Math. And it's basically kind of a love letter to math and modern math and the complexities of mathematics. And it's written for the average person, even though there are some chapters that are not very easy to read. And I first want to show you two animations. So I'm going to show one animation here, and I want to show another animation here. So both of these animations are quite mind-bending and mind-boggling. And this is actually math. This is math depicted on a screen in 2 dimensions for us to actually see. One is related to spinners, and the other one is planet Hopf, which are Hopf vibrations and things like that. I'm not going to explain what those are, but just if you Google it, it's amazing to see that the spinners, so I'll explain the spinners piece. So these spinners are actually spinning 720 degrees to get a full rotation. So everything that we understand in our world, a rotation is 360 degrees. The planet, the sun, whatever, everything that turns, it always comes back on itself in 360 degrees. But these spinners are actually quantum, like tiny things inside of, I think, quarks, and they spin 720 degrees to come back on themselves, which is just like, whoa. So that's one I guess thing I want to show you, that math isn't just 2 + 2 or division or algebra or calculus, but it has all these amazing and beautiful patterns within it, and that's something I was exposed to in this book. So there's a few things I want to talk about here, but as always, go to the post if you want to know everything, or at least everything that I think is interesting. And in there I explain quite a bit about different parts of math, how it came about, the beauty of math, and some of life lessons that I've taken from this book and incorporated from math. So the first thing I want to talk to you about is a guy named Murray. So he's a really important dude, and basically what he did was he discovered quarks, hypothesizing without any tools or anything. So let me explain what quarks are. So we all know what atoms are. Atoms, we assume, some of us assume that atoms are the base, fundamental kind of Lego of life. You put a bunch of atoms together and you get life. Well, within atoms, there are neutrons and protons, which make up atoms, and electrons. But within those, if you break those further, there's actually additional fundamental pieces inside of those, which are called quarks. And these are obviously too small for us to see. And the only way that we'd be able to actually measure and observe these things is by having massive computation, massive machines to actually observe them. But before any of that happened, there was actually an individual named Murray who actually hypothesized about these quarks existing. And the only tools that he had were his imagination and pure mathematics. And to think that someone could be as creative and as kind of intuitive and imaginative around thinking about this just through mathematics is crazy to me. To think that we can have such an important discovery happen through numbers. So the next thing I want to kind of discuss with you is the math that you and I think of, at least when I speak with my friends and myself, we usually tend to think about the math that's been taught to us in school. And the majority of us stick with math up to high school, maybe a little bit in college, and then we move on to something else and we get away from math as fast as possible. Well, math isn't just arithmetic, aka plus, minus, divide. It's not just algebra, it's not just calculus. Math has dozens and dozens of branches within it, and there's two main sections. There's pure math and applied math. And there's a great video, I'll show a quick clip here that you should definitely go watch that kind of explains everything about it.
Modern mathematics can broadly be broken down into two areas. Pure maths, the study of mathematics for its own sake, and applied maths, when you develop mathematics to help solve some real-world problem.
But for now, I just want to kind of share some interesting insights the book provided. So when thinking about these different branches of math, you can think of each branch as an island, right? And there's a bunch of natives on these islands, and they're all building a puzzle, right? So math can be seen as like a massive jigsaw puzzle with, hundreds and thousands of pieces. And the thing with this jigsaw puzzle is there is no box cover, so we have no cover to reference. And when going to build this jigsaw puzzle, each island is building their own pieces, but they don't realize that all these pieces actually have to eventually come together for them to get the entire picture. So some of these islands could be algebraists, I think that's what they're called, that work in algebra. There's geometers, which work in geometry, and there's number theorists that work in numbers. And there are many others as well. There's, I think, harmonic analysis and other things. But the point I'm getting at is each island has their own language. They have their own way of thinking. They have their own problems to solve. And in this book, this individual focuses a lot on this program called the Langland program. And this is named after some individual named Langland, or his last name is like Langland. And in mathematics, you'll realize that the majority of the complex formulas and ideas and concepts are named after people, which makes it that much more difficult to understand. A way to think about this, and a way to think about the benefit of this idea, this theory, this Langland program, is that if the algebraists are working on a problem and they can't solve it, the problem seems almost unsolvable. Well, if you can actually take this theory and actually bridge the islands together and make this problem actually solvable. So if you take this algebra problem that's hard to solve in the algebra speak and language, and you port it over to a number theorist island maybe, or a geometry island, and looking at that problem in a different way through a different kind of native language, these problems become solvable, and sometimes simply solvable. So you're taking something that's impossibly you can't solve it, and you're taking it and actually making it solvable. So this bridging of these islands is actually bringing the entire jigsaw puzzle together, which is really interesting. So there's a lot more to this book. Tons of interesting facts and figures and stories and things like that. But those are two of the interesting things I thought were interesting to kind of tell you about. But before we go, I want to leave you with a quote and kind of a thought that I came away with this book at. So the quote I want to read to you is, "That's how it is in mathematics. Each new result pushes back the veil covering the unknown. But what then becomes known doesn't simply encompass answers. It includes questions we didn't know to ask, directions we didn't know we could explore. And so each discovery inspires us to make new strides and never leaves us satisfied in our pursuit of knowledge." So in reading this quote, it actually made me think about our personal lives and our personal journeys. And when thinking about life, I think about it as basically a never-ending game. There is no winner or loser. It's an infinite game. And in this game, the goal is basically to uncover and explore as many paths and answer as many unknown questions as we can to learn more about ourselves, but also learn more about the loved ones around us. And for example, learning more about ourselves is basically figuring out what are new and difficult or interesting topics that you've never explored but you actually are fascinated by. Why not learn more about those in your lifetime? Another one is finding new interests and hobbies that you never knew you were interested in, or exploring new experiences that will change you fundamentally. And maybe even figuring out what pain are you willing to endure or even enjoy to help others. And pain in the sense that not everybody is good at certain things. So some people love to write, some people hate to write. Some people love to craft, some people hate to craft. Some people love to debate, some people hate to debate. So it's figuring out what thing that you're willing to endure that others won't, to find what is that thing that you want to spend your time doing to contribute to humanity and society. So that's it for this week, all about math. And yeah, let me know if you have any good book recommendations. I'll maybe add it to the list if it's in a topic in a realm that I'm interested in. And sign up to the newsletter, because I send out interesting things, not just related to the topic for the week, but all kinds of stuff. Both helpful, entertaining, useful, and sometimes pointless, but entertaining to me. So, Internet, I will see you next week.